All right, we have Chris LaForge here who is going to answer a question for us. What is the best practice for commissioning a residential PV system that has battery backup?
Well, Britt, it's a pleasure to be working with you and have this chance to get ideas out there. As any good question goes, there could be a very decent module lasting 8 hours on this subject. So I'm going to hit the highlights and then point in the direction of where you find more information. But I think on the residential and small commercial scale, commissioning is very often neglected. It's not seen as just a standard part of the plan of a system design and installation as it is when you get into commercial and industrial and utility scale. In part, that's because we're starting to be comfortable with these systems being normal or, more typical in people's lives. But unlike a new car where, the dealer hands over the keys and you drive off and you have your insurance on it and you go because you've driven cars and you know what you're doing. A PV system with energy storage, once you choose batteries, has a complexity that the client really wants to know better, even if they don't think they do. They're starting to be handed over without much commissioning, and I find that as a problem. So the first thing I suggest is plan the commissioning process first during your design. So when you're working with your clients out there, say, okay, well, once the machine's ready to run, we're going to have this commissioning experience, and it's going to contain these elements. And I'm going to hit those right away. The first thing in commissioning is the mechanical side. You're going to go through, and even though your team is fully qualified and ABCEP certified installation professionals and everything, you go and you do a spot check on the torque on all your connectors. So you check some module connectors, torque specs, you check the rack torque specs, and get some feedback from the installation crew as to how it all went, and inspect everything on the mechanical side of it. This is very important to do from a quality control perspective. And I've spent a lot of time teaching contractors on the general design installation process. And I think commissioning might be seen as kind of a profit killer in the sense that it's going to be time spent that doesn't create more revenue. You're not selling more parts. You're not selling any systems. But think about it this way, folks. You're avoiding callbacks by making sure you have a commissioning agent either on board or, when we get to larger systems, it's usually a third party, come in and check the mechanical. You don't end up with modules dangling off the side of a rack, which this installer and instructor has seen, where we're in a windy place. We've been called in to fix systems where modules were being restrained by the wires and bouncing off of things off of its full mounted rack. Why did that happen? Installation crew didn't torque. And that's the bottom line. You got to have your torque specs. You got to make sure they're met. And commissioning should do a nice sampling of all the different connectors, prove that you've got your torque specs met. The next step after you've done a thorough mechanical inspection, which includes how the inverters are hung and everything in between, you're going to move into electrical inspection. And now you're going to look at all your electrical connections. You're going to make sure that this is something that a lot of installers have neglected. You have a torque screwdriver, because every terminal that we make a termination on has a torque spec. And everybody knows a loose connection can, start arcing, can start a fire. Most people don't readily know that an over-tightened and over-torqued connector in an electrical circuit can create resistance too. So you don't just want the German guten tight, that's very tight there. We got that guten tight. If you over torque, the reason they give you a torque spec is if you over torque, you're going to have resistance. It's going to degrade the performance of your system out of the box. You don't want to over torque. You don't want to under torque. You want to have a torque screwdriver. And I know a lot of guys are rolling their eyes right now. Yeah, right. The Forge, I'm going to torque every connection. But short of doing that, you're setting up a potential callback that can be very costly and an unhappy client. You don't want either of those. So then, with these kind of systems, the batteries, the energy storage element provides services to the client. Now, on residential scale and small commercial scale, oftentimes primary service is resiliency, battery backup during power outages. And that's great, but that's kind of a dumb battery. And we want the batteries to do more. So at a minimum, you want to be able to adjust the uh, deployment of your solar into different rate tariffs so that you can get the most revenue for when your solar goes onto your grid. And you want to use that battery in as many additional services as possible. And we go into this in all our courses on photovoltaic systems with energy storage. The smart battery, even if the utility you're working with is still kind of a dumb utility and they don't have a lot of smart grid opportunities, these are coming and they're coming quickly. So you want the system to have the different opportunities to provide more services, and you're there setting up the system, getting it ready to be run. You want to test each of those services, even if they're not currently going to be used. The interesting thing about this is once you test for each service, you've really gone through and made a good operational test of the system. You want to imitate a power outage. This is critical because on a residential scale, one of the big primary services is battery backup. Hopefully you've done the design the way we taught in the course, and you've got a load profile both for the whole building, and if you're not backing up the whole building, which many systems do, you've got a load profile for the critical loads. You've designed that period of autonomy that the battery will provide for those critical loads clearly, and then you test it. And this is where the tire meets the road. The client was in on the plan as to what loads were there to be powered during power outages. General whole house backup is kind of a default that many equipment manufacturers are going to. This is kind of a loser from my perspective, but if you're going to general full house backup, you need to do more training of the client so they can be happier. Because the first thing that'll happen is when you've got a 10 kilowatt hour battery, we're not going to name any names here because they're all great and they're all different. But if it's 10 kW, you probably know who I'm talking about. That's an amount of storage that for the average household with, 30 kilowatt hour demand during a day is going to consume very quickly. And that's not why they bought the battery for resiliency. So they have to understand that load moderation, if it's not already programmed into the system, is something they can do. And then they have to be trained on how to operate the system so that they know what battery reserve they have during a power outage. Most of our power outages and most utilities are very brief, 2, 3, 4 hours. Designing that much autonomy may keep people happy for a while, but we need to remember that the owner operator has to know what the limits are. So a big part of the end of my commissioning is going to be confirming that I've trained the operator. This is usually the homeowner, business owner, and a lot of the operational aspects of it is monitoring. You look at your battery state of health. Over the years, it's going to decline. I don't care what kind of battery you're talking about. They are going to be less efficient. And you really need to know that so that you know what you have under the hood of your car, so to speak. In the process of training, you should be able to watch the owner operator manipulate the system to their liking. And this is where, during the power outage period, I like to make this a real educational time. I've already trained the owner how to work with the system to operate it more effectively. And then we turn off the main breaker to the building and we watch what happens. What happens oftentimes is the client will identify a load or two that they didn't get into the load profile that they're trying to power when we do an isolated set of secure loads. This is a great thing to achieve before a real power outage. Because what happens if you don't do this? The real power outage comes by, and maybe it's an ice storm that takes a day and a half to go through and get you back online at your client's house. And the client is surprised at how dead their battery is. Or they're surprised that they don't have any lighting in their hallways at 10 o'clock at night when they're trying to get around their house. Or they don't have the right communications power so that they can operate their communications and understand, how other people are doing and what's going on in their world. So the final step, in a large scale commissioning, you've got your functional mechanical test first, and then you have your operational test. I suggest you want to do pretty much the same thing. And that final operational training has to go through all the services. So if you've got like time of use billing, so that your utility is already giving you 4 or 5 rate structures, you want to deploy that PV most intelligently for the best revenue. You want to operate that with the client so they see it, because most of our equipment is not operator services. They're going to call us to fix it. But if they don't operate it from the observation level, they won't know if their services are really not being met until the bill comes. And they thought, well, I'll get a 40% reduction in my bill, or I'll eliminate my electric bill except for the service charge. And then they'll get their bill and it'll still be coming in as, lost revenue. That's a callback for you. So all of this commissioning and this training for your clients leads to very good customer relations, leads to good recommendations from your clients, and no callback. We are going to go in, I've had the opportunity to commission hundreds of these systems in the last 32 years. And because I always made a point to do really good consumer education and then follow through with a good commissioning that shows them what they should be looking for, I've had very, very few callbacks. Knock on wood, next to none. But I put that savings up front by investing in my client's knowledge base. A trained client also is a lot more fun to talk to on the phone, because they can usually find the breaker that's blew and observe why it's blew and fix the problem and turn the breaker on, and you don't have a truck roll. So anything else that you think of on your side, Brett?
No, that was a great answer to our question. Thank you so much for providing that to the community.
It's a real pleasure. We have modules very specific to commissioning in our classes, and they get more in depth into it. So if you're looking for some more meat to put on the bone, so to speak, speaking as a vegetarian, take a look at all the courses that we have over on HeatSpring website.
Awesome. Thank you, Chris.
You, Brett.